Good day, everybody. This is again Thomas coming back to you here, and we're back for our second round here with Hyper-V. Last time I went through all of the quick settings and showed you a little bit about how it all gets set up and what you need to understand about it. So from here, what we're going to do is we're going to go and we're going to do a new virtual machine. Got to start somewhere, so let's get busy. Go over here and click that link. Basic information before you begin. Nothing to really worry about. So go next. New virtual machine. Well, we're going to create our first Active Directory machine, or Active Directory AD system here. And from there, what we've got to do here, you can tell it to store the virtual machine in a different location than your default location. You notice our location is the one that we set earlier in the system settings, or the Hyper-V settings. So at this point, we don't need to change its location. We're just going to hit next. Now here, our generation of virtual machine is important when you choose this. Microsoft says anything after Windows 2008, including 2008 and beyond, should generally be using a Generation 2 type virtual machine. The Generation 2 virtual machine gets better performance primarily because it uses a SCSI interface, a virtual interface with the hard drive specifically. It also gives you the options of managing the hardware on the fly. Some of those specific ones I'll show you. Generation 1 machines are generally referred to as the older operating systems. Linux, anything that is 32-bit operating system needs to be using Generation 1. Windows Server 2003 basically needs to be Generation 1. The other one is if you are virtualizing an older machine, say an 03 server or even a 08 server, and you are going to bring it up live, and it has had physical equipment that it was installed upon, you are going to want to use a Generation 1. It gives you access to legacy hardware equipment. Downside is you're stuck with an IDE drive, even if the physical server that it came from used a SCSI drive. So we'll get into a little bit of this as we go. For now, since this is our Active Directory machine, it's going to do our domain. We're going to choose Generation 2 because we want it to perform well. So, and also you can't change your virtual machine generation type once it's been picked. You have to start from scratch. So we'll click next. Here's where we specify the amount of memory that we're going to use for this machine. This is not etched in stone. You can change it later on. It gives you the startup memory. Basically, this is the memory that it is dedicated to no matter what when it starts up. If you uncheck the check mark box and use dynamic memory for this virtual machine, this virtual machine only gets what you have put in the startup memory, and it does not expand or contract. Very useful for SQL machines and different machines of that nature. In this case, I'm going to use dynamic memory for the machine, but I want it to use 2 gig in particular to start up, and it just does it quicker because with virtual technology your processors are capable of doing so much, but you're needing memory is what you're needing, and you use memory a lot. So let's go ahead and click next now. Now here we go. This is where we specify where we want it to be connected to. This is our virtual switch. Now if you notice, we have default switch and external. What we're going to use is external. You can make it till it's not even connected if you're worried about it. In this case, we're going to use external because I want this machine to be able to talk to my entire network when it's all said and done. Click next. And now, if you had a virtual machine hard disk that you already have sitting on a drive ready to be used, this is where you would get a chance to put that in. So basically this tells us what it's going to be named. It normally names it whatever you've given the name of to your virtual machine. You do have the ability to change it if you wanted to right here. The VHDX is an expandable, auto-expandable virtual hard drive. That's what the X means. If it's VHD, you have to physically go in and expand it when the time comes. The location, again, is our default location where we wanted it to be put. The size, basically it tells us how big we want it to be, and the maximum that it can be is this big, 64 terabytes in this case. I believe that's Microsoft default. So, we don't really need it to be this big, this size. We're going to limit it down to about, I don't know, we're going to do a 40 gig hard drive at this point. The OS system files are pretty small, honestly, and we're going to let it create it. Now, here, right here, is use an existing virtual hard disk. This is where you would be able to go and point to that one that you have on your drives already that you want to use. For instance, if you got a copy of the 2019 Server OS from Microsoft, an evaluation version, you could pull it up here and use it. So the next one down is actually attach a virtual hard drive disk later, and basically what that means is it'll give you the option to put a hard disk on it later on, and that's used if you're just wanting to get the virtual machine itself prepped and ready, and later on you're going to put a drive with it or make one for it and finish out later. There's multiple reasons why, but most of the time if I'm making a virtual machine, I'm either creating a new disk or I am using one that I've already got. So we're going to click next. Installation options. You can install an operating system later if you wish, or you can install an operating system from a bootable image file. That's an ISO file for those that don't know. Right there it tells you. And you can download the 2016 server version from Microsoft directly, and it's an evaluation version if you wanted to get started with it, or if you wanted to make a Windows 10 virtual machine just to have one, you could do that as well, because you can download the ISO for that operating system, and honestly it doesn't even require you to do the activation of that Windows 10 version. You can skip cancel on it or go around it and use it. The only downfall is you don't get to personalize your desktop on it. That's the only thing. And the last one is install an operating system from a network-based installation server, from which honestly I don't have right now. At some point we're going to do that though. We get everything done and the virtual machine's in, we'll set a virtual machine up to be one of these network-based installation servers, because they are very, very handy. In this case, we're going to install an operating system from a bootable image file. And then we're going to go find it here. I believe that it is... Let me think real quick. Is it down here? Oh, there it is. Now see, that's the evaluation version that I have there. I've also got CentOS, which is very nice. Do I have the other version of 2016 in here? No, I don't. Okay, so we're going to do the eval version of 2016. Let me find it here and get it going. And what I'm using is, it's the Datacenter release. It's about a 6 gig ISO, and then we're going to click next. This is a screen, it's just telling you how it's going to be set up to begin with. Nothing in particular that it'd be worried about or anything. And then we're going to click finish. It will create the disk where we wanted it. It will create the virtual machine. And at this point in time, that is all we had to do just to get a virtual machine set up. Now, from here, there's other things that you're going to want to do. Primarily, go through the settings of this virtual machine before you ever try to start it. These settings are important to understand. In the questions from Microsoft, they ask you about a lot of these. So, add hardware gives you the ability to add these devices. Remote FX 3D video adapter only. Well, actually, they're no longer even supporting those. Once upon a time, they did. You could put a fiber channel adapter in. You can put a network adapter in and a SCSI controller. Say you wanted to put another SCSI drive in this machine, or in this case, another virtual hard drive. You can throw another controller in there and attach a drive to it. Or, actually, if I remember correctly, you can add another hard drive right here. We'll do it just for, see, it just drops it down below it. Now, we're not even going to bother with this. It's just for show. The DVD drive or shared drive. Shared drive is just what it sounds like. Just a shared drive between it and another machine. Which VHDX is the only way that you can share a shared drive. It would be a VHDX. The VHDs will not share between machines, by the way. That is a Windows Server question that they ask in the very first test of, I believe it's 70-740. It's in that test. So, let's go back to the top. Firmware. Boot from DVD file is what it's selected as right now. And that's where we want it to be. When it actually sets up the OS here in just a little bit, when we go through that, you basically will be, when you look back at this, it will change these around until the hard drive should be at the top at that point in time. That's where we will want it to be when we're done. Under security, the security enables us to do secure boot. It also, if you have a TPM module in your machine, which I don't, it allows you to do the encryption support. TPM is just a chip inside of on your system board that allows you to, it's a cryptographic services compute platform chip is what it is. And it allows you very tight security over your virtual machines. It also allows us to use shielding. What shielding is shielding shields this virtual machine from the OS of its actual host. is what it's supposed to do. Meaning that if we tried, once it was all set up, to do a quick file transfer or something, just drag and drop, it won't do it. You have to go through the long way and go the right way. Another major security thing that they talk about on the tests. So the next one down is our memory. Our memory is what we was talking about earlier. So here is where we actually get to set up the minimum RAM and the maximum. Our startup memory is the 2048. I don't want this machine not to have less than 2048 meg. So I'm going to change this minimum amount of RAM right here to that. The least that you can go down to with a virtual machine is 512, and honestly, you don't want it to sink that low. The maximum is the maximum that you are willing to allow it to climb to. In my case, let's see, 4096 is 4 gig. I don't want it to go below 2 and don't really need it to go above 4. The memory buffer, about 20% is standard. Memory weight, you can change this depending on how you want it to start when other virtual machines are running, and available memory as well. With an Active Directory server, most organizations have more than one. So if one server that it's on is low on memory, another Active Directory machine should kick in and respond. Hopefully not on such a bogged down machine. So I leave this at default most of the time for most virtual machines. Again, I've been doing this sort of stuff now for 20 some years, and it's worked out fairly well for me. So the next one down in this is our processor. Number of virtual processors. Number of virtual processors does not correlate directly with either the physical cores in the CPU or the threads of the CPU. The number of virtual processors, according to Microsoft, is a direct link of how much processing time you get. You've got 100% of processor time. If you go in here and you crank this thing up to the full number of threads you've got in your machine, you get 100%. So watch, we'll show you here. Notice that number of percent of total system resources. You can actually overdrive it if you really wanted to take a chance. Not the keenest thing to do. You don't even want to take it up to 100% of the time. And that's what it is. It's a percentage of the time of processing that you get. So if you set it at 2 processors, like in my case, I get 16% of the cycles of a normal run on the processor for this virtual machine. So each time that this processor goes through its instructions, this machine gets 16% of the available area for processing, and it does that routinely each time. Whether it will need that or not is another question. Now, you can also total virtual machine reserve percentage. Basically, those are used for if you need, just like it says, a reserve, you can set that. Most of the time I don't need to. The percent of total system resources right now set at 0 because of that. If we change this, it changes it as well. Notice the percentage of total system resources. See, that tells us that it's going to reserve all of its processing power and we don't want it to do that. We want to keep there. So the virtual machine limit percentage, we want to be able to give it full throttle when we need it. We leave that at 100% unless this is a laggy server, or not a laggy server, or unless it's a server that's not really in use. You leave it at 100% because you want it to be able to use what it's got. The relative weight, 100%, same deal. Hyper-V is not configured to enable processor resource controls. Now, what that means, this line right here, is that you can, with newer versions of Hyper-V, actually assign specific nodes to the machine, or in this case, specific hardware, as in processor threads. I don't deal with that, simply because then you're locked down to using only that thread. If you were in a situation where you had a very strict and very tight network, or a company where you wanted to make sure nobody got to certain things, or somebody couldn't get to it, that would be an easy way to actually keep hackers from getting to that CPU. If you're using all across the CPU, and a hacker was able to get in and lace code into the memory, they could then, if you were using this method, get into your virtual machine with that code. I don't really worry about that a whole lot because we use firewalls and other intrusion prevention services. So, next thing down the line is compatibility. This is used to migrate a physical computer with a different processor version. Those are specific. We're talking about from a Intel server to an AMD server, processor style, or in some cases even from one Intel version to another. Most of the time you don't have to worry about it, but I have seen in the past where issues arose if I didn't do this, from using it on a specifically like a home PC, from, we'll say, an i7 backwards to a Celeron, or vice versa. So you want to use that if you're going to move it to a different machine later that is specifically a totally different hardware. Make sure that's checkmarked. The NUMA nodes. Okay, we've got a possibility in this machine of 2 processors with 1 NUMA node per processor, 1 socket. So basically, I've got 6 cores on my Xeon processor with hyper-threading involved. The maximum number of processors in this machine comes up as 12. Maximum amount of memory that I have in this machine actually is right at 24 gig. But with Hyper-V, Hyper-V is designed till it will not choke out the host. So it will always release memory if the host is needing it. And it will pull little bits from here and there unless you have it specifically locked down. Again, it won't kill your host. Not on purpose, at least. The maximum NUMA nodes allowed on a socket is 1 in this machine. Hardware threads per core. In this case, we have 2 hardware cores, or hardware threads per core. Basically, it tells you if you want to just leave it and inherit from the hardware itself, specify 0, and this will take care of it. There's processors out there that have multiple threads per core, specifically AMD hardware or CPUs. Some of them new thread rippers are beasts. then you can use actually the hardware topology to bind to the physical hardware. I don't deal with that. It's more pain than it is worthwhile to try to keep up with. It's something that's available. So now we're down to our SCSI controller. Now if you notice, we've got, like I said earlier, the option of 3 different things there. You can add those at this point, and it just adds it to that controller. If we wanted to, we could actually install a second controller. The second controller basically would be specific to another drive setup. Or you could remove one if you needed to be. If we go down here onto hard drive and expand it, we see it's connected to a SCSI controller, of course, in this case, and it's in position 0. SCSI disks a long time ago, or still do really, they have a chain number, and that chain number is where it's at on the controller. 0 in this case makes it be the bootable one in this case. The media, it tells us what it is. It's a virtual disk. And here's those buttons I was talking about earlier, the inspect, the edit, and you can create a new one if you wanted to, a virtual hard disk right from here. You can edit what you've got. If you hit edit, basically it gives you these options. If you have problems with your drives or your virtual machine starting up sometimes, a lot of the time coming in here and running compact on it, just choose it and the defaults from there, it will fix that VHDX. It compacts those files, repositions the files, and makes it to where the operating or the host is able to use it again. Converts from one type to another, just like it sounds. With a VHDX, if you convert back to a VHD, you can't go the other way. Expand is just that. It will expand your disk. If we click this, notice it gives us those options. We can actually go up new size. And it tells us, well, it's 40 now. You want it to make it 41? No, we don't. We want to go back here. Convert gives us those. It tells us, what do you want to format it to? Or change it to? Well, it's coming from a VHDX, right? So basically it supports big drives, very big ones. VHDs only support up to 2 terabytes in size, just like in real life on physical hardware. 2 terabytes is the old style, not so much now. Windows 2003 server and 2008 server, I believe, was that way. When 12 came along and 16, that was thrown out the door. VHDX, so on and so forth, tells you about that. So then it asks you, what do you want to do? Basically, you want it to be a fixed size or dynamically expanding. A fixed size basically gives you better performance because it doesn't have to worry about where it writes that data to on the drive. It allocates that file size, and it doesn't have to jump from sector to sector to find a new spot if something else has been written just after this machine was started. So dynamically expanding can cause slowness. The convert option fixes some of those issues, and if available, it will. So let's go back here to this. We're going to go ahead and cancel out of that. The inspect button does just that. You're able to see what it is, where it's at, file name, its current size, and its maximum size, which is handy. The browse button basically allows you to go and find another disk if you need to. So we go on down here, quality of service. This allows you to enable the amount of IOPS in and out, or out in a specific method here. They're measured in 8 kilobyte increments, and basically it's the amount of disk access you get. Defaults basically are where they're at. Don't even worry about it. And if you did enable quality of management service, you just accept the default and go on if you really want to, and it will handle it. And it also gives you a storage policy, service policy, if you wanted to go in there and, change it. So we're not worrying about quality of service. Here's our DVD drive. It tells us where it's at, and look, number 1 on the location, which means, it's on that same SCSI controller, because the hard drive was 0. So now it tells you, specify where it's used at and whatnot. You will want to set this to none after it has booted up and you've got to log into it. You'll want to set it to none unless you are actually using it. There's no reason otherwise to have it set to anything else, unless it's something that you need to use on the server, such as a software ISO, like for we'll say SQL or something that you're installing that way. So we come down to the network adapter. Network adapter, we've got it on the external. Again, we can change the VLAN ID right here. And bandwidth management, if you really wanted to make sure that this machine got a specific amount of bandwidth, this is where you do it at. It tells you the minimum amount right here. And say that you're on 100 gig LAN and you want it to have 10 gig no matter what, that's where you would put it, right there in the minimum bandwidth setting. So then we go on down here, hardware acceleration, enable virtual machine queue. That's normal setting, you need to enable it. The IPsec task offloading, it only enables if your machine is capable of doing it with the network adapter, and in my case, and in most cases anymore, they are able to do it. And what it is it allows the network controller processor to do more of the job instead of the processor in the server. Advanced features, you can set your own MAC address if you really want to. Otherwise, it's a MAC address that is designed by Microsoft. The first 5 is always going to be the same, or the first 6, or the first 3 octets, they're always going to be the same. The second 3, I believe it is, changes as your number of virtual machines grow. So MAC address spoofing, you can turn that on or off if you're worried about it. Just keep in mind, this is why. Just make sure that the packets are going where they're supposed to. I usually turn it on. DHCP guard only allows authorized DHCP servers to give this machine a IP address information. If you're using just a plain old router or something that way to do this, and it's not a Microsoft authorized DHCP machine, which we'll get into later on down the line, basically don't bother with it. Router guard, same way, same deal. Although the router it makes sure that it's not a router and not a virtual machine is what it does. So I usually check it. Protected network, that's an interesting setting. Basically what it does is allows us to have this Hyper-V machine. If it is linked with another, it can move these virtual machines off of this machine onto another if needed. And in this case, the network, if the network card goes down, or say the switch died that the network card is on, and it realized that, and you had a backup network set up for migration, it would move your machines over to that other Hyper-V machine. That's what clustering is all about, and we'll get to that point too. So port mirroring, we don't set that up, don't need it. NIC teaming, another interesting one. If you enable NIC teaming here, basically you take two virtual machine network cards and inside of the virtual machine and use them as if they are one. And what it does is it gives you a little more bandwidth, is what it really does. However, what it doesn't do is allows you true actual failover support, because if one of the network cards happen to go down, or you're using just a single and use this to try to get more bandwidth, if the switch goes down, that NIC team is going down. It doesn't give you the same options as if it would if it was a physical server. Basically, I do NIC teaming internally on my physical machine, not the virtual, and that way all of my virtual machines have failover capability. Device naming is supposed to allow you to get your network name or your network adapter name to be propagated into the guest OS systems. So for instance, the fact that we have our virtual switch name external on the machine, if we was to go into our network properties and find that virtual machine network card on this PC and then change the name to Timbuktu or something, we would be able to set up this machine, get it booted up, and actually go find it, and it's supposed to propagate that into the OS. I don't bother with it because I like to name my my network cards for the network that they're on or the VLAN that they're on. It makes it simpler for me to know exactly where they're at. So we go on down to under the management. There's the name. You can record notes below it about the machine. In this case, this is going to be our primary active directory services machine. And we go down to integration services. With the integration services, it gives you these options. Operating system shutdown basically allows us to be able to shut down the operating system from the virtual machine or from this server. Time synchronization passes the time from this physical to the virtual. Data exchange allows us to exchange data from one machine to another. Remember that setting back there where in the security, if we didn't want to allow it, there's another way. The heartbeat is basically a way for the Hyper-V manager to know that, hey, it's up and running. It sends out little pings every now and then. The backup for volume shadow copy, that's exactly what it's for. And guest services. I don't bother with guest services, to be truthful, because it's just not needed in most cases. We go down to checkpoint standard. Now, before I go there, under integration services, something that you need to understand. That time synchronization, if you're using a NIST server or an NPT server set up on your network, in this case a NIST server basically allows the time to flow from far away in, and basically it just synchronizes your time on your clocks. NPT actually goes backwards and goes out to a GPS clock and is set up physically on this server, on your Active Directory server, for time synchronization. That is a specific thing, and the reason that I'm bringing this up, if your Active Directory machine is, and usually is, the one that runs your time synchronization, you don't want to check that box right there as time after you've got it set up. You want this to be your default machine, so it is the one that would be unchecked for time synchronization, and all other domain servers would look to it for their time synchronization. In normal circumstances, if the time gets off by more than 3 minutes on a machine that is connected to a domain, it will not be able to log in. Even if you've got the right credentials, it won't log in proper. So, on to checkpoints. Checkpoints, you enable them or you don't, to begin with. Checkpoints allow you an easy way to try new things on the server. If this is a production server or an R&D server, checkpoints are a way to where you can put a software package in and see how it works, and if it doesn't, you can go back to an earlier checkpoint. In this case, we don't need checkpoints. They're non-used in Active Directory. So just remember that. You do a checkpoint on an Active Directory and then restore it to it, your Active Directory is hosed. It's gone. So on down here to Smart Paging file, it's going to put it in the same place as all of the rest of the default files, and you want it there. And yes, even though we're using RAM, physical RAM, to run this machine on, it needs some virtual memory space. Actually, the virtual memory is, or the paging file, is our indication of how well the memory is working for that machine. If you end up with a very large page file, the problem is you don't have enough memory assigned to that virtual machine. So we leave it as it is. Automatic start action. I normally set it to automatically start if it was running when the service was stopped. The Active Directory machines, basically I start the virtual machine automatically no matter what, and I usually give it a start delay of about 30 seconds. And the reason being, I want to make sure the Hyper-V machine is fully booted prior to it trying to start that virtual machine. And we go down here, save action. Now there's different thoughts and theories here, but basically here's how it works. If you save the virtual machine state, what this is all about, say somebody walks up, they press the power button on your Hyper-V machine. If you press the power button on a machine long enough, it's going to usually turn it off. That's just our BIOS. So if it goes into a shutdown on this machine, it's going to save the virtual machine state of that machine. Another thing, if I was to go in while they were running and tell it to physically shut down the machine, as in the Hyper-V machine, I was going to reboot it for whatever reason, and I didn't think about it ahead of time and realize, oh, I've got virtual machines up and running, and then go and tell it to do it, it will save the virtual machine state. However, when you bring the machine back up, you have to go in and tell them to start back up. And you have the option to turn the virtual machine off, which it would attempt to shut down every virtual machine in that case when the power was, when it was told to shut down. or you can just shut down the guest operating system. Not doing anything, so to speak. It's something that I don't do. Normally what I do is I turn off the virtual machine, and that way I don't have to worry about it. We're going to click the apply button, then we're going to click OK. Now from here, if you notice, we've got this pane down here at the bottom, the name of the server. If we look at the summary, it's pretty generic at the moment, and it tells us that it's not clustered. The configuration version of the virtual machine is 9. The generation 2. And there's our notes. We click over on memory. Under memory, basically it shows our startup memory. Our dynamic memory is enabled and gives us our minimum and maximum amount allowed. If it was assigned specific amount of memory and its demands, if it was up and running, we'd see information there. Under networking, we basically see this right now, that it's dynamic, not assigned, and later on we'll see its IP address and status. So with this, I think we can call this little information gathering session a wrap, and when we come back in our next session, the object of the game is to actually start that virtual machine up and go through the setup on Windows 2016 Server Datacenter evaluation version. So until then, I will see you in a little while. Talk to you later. If you all have enjoyed the content and liked the tutorials that I've put out, please, I would greatly appreciate a like down there. Click that button for me, and if you want to see more and be notified of future videos, go ahead and click that subscribe button as well.